sediment in the water gives it a brownish-red appearance, and before the recharge phase could begin, it was necessary to wait for the water to settle. The wide brown expanse of water soon changed. The sediment settled, leaving the water clear and sparkling. The largest recharge areas were the downstream river basins, divided into two by rock barriers and covering 72 hectares. The changes in the basins and dam area were monitored to determine the effects on the environment. Environmental engineer Harry Goff.
These are river gum seedlings. There are thousands of these around the western edge of the Ophthalmia Dam. They've been one of the more notable effects of the dam's filling and its subsequent drying out. Environmental monitoring of the impact of the Ophthalmia Dam has involved the establishment of 3 baselines in the area. The first baseline is downstream from here, in an area that is subjected to restricted flow as a result of the dam's construction. The second baseline goes right through the flooded area and onto dry land on either side of the flooded area. The third baseline is well upstream in an area that's unaffected by man or the dam. To date, the monitoring of the upstream baseline has served to illustrate the dynamic nature of the ecology of the Pilbara area. The action of the floodwaters has been to kill off in the flooded area the low shrub and grasses. As the water recedes, these shrubs and grasses are being replaced by annuals, ephemerals, and the river gum seedlings that we've already seen. We don't expect all of them to survive, but those that do will greatly aid in soil stabilisation as the dam dries out. Monitoring of the environmental impact of the Ophthalmia Dam is a continuing thing, and we feel that the effort we are putting into the environmental monitoring will be a valuable contribution to the understanding of the ecology of the Pilbara.
In addition to the dam and the river basins, the scheme includes 4 excavated recharge ponds, covering a total of 11 hectares. All the recharge facilities are located downstream from the dam, directly over the most depleted parts of the aquifer. Although they're smaller in area, the artificial ponds have higher recharge rates because of the extremely permeable materials beneath them. Following the settling period, recharging of the aquifer itself commenced. Water was transferred from the dam to the recharge areas via the canal. Once in the ponds, the water then makes its way into the aquifer by natural infiltration. The success of the Ophthalmia Dam project was confirmed by monitoring all stages of the recharge process. In all, and allowing for only 1 wet season, the Ophthalmia Dam has fully justified the time and expense involved. This summing up is from the company's chief geologist, Mal Nishaw.
The dam and recharge facilities represent the end result of several years of detailed investigation and feasibility studies involving many people. But it also represents a starting point in what will be a learning process, learning how best to manage the spread of pumpage and recharge in the aquifers, and learning how to overcome operational problems, some of which we don't even know exist right now. Pond cleaning is one example. But to summarise the first year's experience, it's gone as well as, or even better, than we expected. In the first 5 months season, we recharged some 8 million cubic metres through the river basins and off-channel ponds. At least an additional 2 million cubic metres went in through the west abutment of the dam to areas where it was needed. So a total of 10 million compared with a target recharge figure of 6 to 7 million per year. We're starting to come out of the red. Our job from here on is to closely monitor the overall system and learn from that experience. What of benefits to Australia, to other people involved in water resource planning and management in similar semi-arid areas? There's a lesson here. Locally, the obvious one of an assured and safe water supply for the town and the mine. In the longer term, we can look forward to an improving water quality to the town, and of course the recreational aspects of the dam for the townspeople.
Pilbara in the high 30s with light.
Where's your brother? Still asleep, is he? Good morning, Christopher. Hello, Jody.
On the edge of the Gibson Desert, almost astride the Tropic of Capricorn, sits one of the world's great iron ore deposits. Mount Whaleback in Western Australia's Pilbara region is the world's largest open-pit iron ore mine. Iron ore was first discovered here by Stan Hilditch in 1957. In that year, Peter Laver was just 17 years old and thinking of becoming a metallurgist. Peter went on to achieve his ambition and in doing so got to know a great deal about the product end of the steel-making business. He's one of the line of professionals to have had the responsibility for a $1 billion mining and enrichment operation for the Mount Newman Mining Company.
Morning, all. Morning, guys. Morning, Peter. Morning, Peter. Morning, Doc. You go. Thanks. Morning, Chris. How things? Morning, Peter. We had a pretty good run. Pretty good run yesterday. Got about 50,000 sale and about 130 crushed ore. All stockpiles of the quarter on grade.
Well, when's the next blast?
Friday. And we'll be firing in this area. There's not much high grade and it's mainly waste for advancing the benches to the north, but it'll free up the faces down here.
Is that a full clearance, Chris, that blast?
No, it's the crushers will be right, Peter, in this area, but we'll put roadblocks through here and it'll just maybe the east bit. We'll fire at quick time, so it won't affect production substantially.
In its first full year of production, 1969, Newman took 6.6 million tonnes of high-grade ore from the Mount Whaleback deposit. Since then, they've mined over 400 million tonnes, with a designed annual capacity of 40 million. Production schedules are maintained by utilising such specialised systems as double-sided loading. The spacious benches and wide-open faces allow huge shovels with bucket capacities of 50 tonnes to serve giant haul packs on alternate sides. The Mount Newman team is made up of about 4,000 people from 40 countries. The equipment they use for winning ore from the ground is just as diversified. Haul packs ranging in sizes up to 190-ton giants are serviced by 20 electric shovels. As well, there are drilling rigs, loaders, dozers, trucks, rock breakers, cranes, mobile workshops and more. Their job is to keep the ore moving, 24 hours a day, 7 days a week. A general workshop and specialist facilities for vehicle and tyre repairs keep the massive fleet operational. A top team keeps the equipment online.
4 for overhaul and a few more for service work.
Okay, that's fine. We'll try and get those out tomorrow.
Looking to the future, the company envisages having 400 young people in apprentice training schemes, for it's these experts of the future who'll keep the ore moving. The heavyweight equipment is used to strip millions of tons of desert overburden to reveal the rich blue-grey hematite of the Mount Whaleback deposit. The haul packs transport the ore to either of 2 primary crushing complexes. Housed underground in concrete bunkers, they reduce the material to less than 200 millimetres. Between them, the two crushing systems are capable of handling up to 160,000 tonnes a day. Conveyors feed the ore to the secondary crushers, where the particle size is further reduced to less than 100 millimetres. The output from the secondary crushers is conveyed to transfer stations, where two rail-mounted stackers lay the ore into stockpiles above the automatic train loading chutes. Before it's loaded, it's tested. Quality control is an enormously important aspect of the mining operation. The step-by-step sampling and assay program makes sure that the ore meets the product specification. A technically sophisticated laboratory forms part of the 65-hectare support complex adjacent to the mine. Continuous tests are conducted using the latest in analytical equipment. There's not a move that's made without careful pre-planning and preparation. And at every stage, rigorous scientific analysis ensures that the desired result has been achieved. Comprehensive mine surveys give the production team a total knowledge for mine planning requirements. The ruby glow of the laser helps to determine the future shape of the mine. Geological and survey results gathered in the field and the laboratory are fed into a bank of digitizer and computer equipment, which gives the technological edge in efficient mine planning. It provides speedy and accurate assessment of reserves and their grades and allows mine planners to optimize mining programs for specific ore types.
East.
Using this technique to outline the incremental mining system assists planners in bench selection to make sure that correct blends are sustained. It saves many man-hours and minimizes the risk of human error. The result of this detailed mine planning is as much in evidence at the new Maramamba mine across the valley from Mount Whaleback. Maramamba ore is an extremely suitable blending material, being low in such impurities as silica and alumina. Already it's proving its worth with steelmakers and helping to extend the life of the Whaleback deposit. So far, the geologists at Mount Newman have located more than 40 ore bodies on their leases, giving a potential of 6 billion tonnes of ore of various grades. Mount Whaleback has proven reserves of well over 1 billion tonnes of high-grade ore still in the ground, and Maramamba has almost 300 million tonnes to contribute. Additional high-grade measures include ore body 25, 50 million tonnes, ore body 18, 100 million tonnes, ore body 24, 200 million tonnes, ore body 35, 60 million tonnes, ore body 32, 50 million tonnes, ore body 42, 24 million tonnes. And Mount Newman's personnel has the expertise to mine, mix and move it to the markets of the world. Trains of 180 cars behind 3 locomotives load from 2 concrete tunnels below the ore stockpile at the mine. Filling 13 cars at a time, the automatically self-choking gravity feed system takes just over an hour to load a train with almost 18,000 tons. Until recently, not all the ore that was mined was able to be utilised. The inability to separate contact ore from waste meant that some of Mount Whaleback's valuable reserves were being dumped. Now, the mixture of medium and low-grade ore and adjacent waste material provides the feed for the $85 million fully automated beneficiation plant, the only one of its kind in the world. The principle? Simply iron sinking through a high specific gravity medium. The larger particles are fed into slowly rotating drums. Iron ore sinks through while the lighter waste floats away. The fines particles are separated by a unique Australian invention called the Reichardt cone. It uses a stream of water flowing over an inclined surface to separate the ore from the waste. The plant is able to extract more than 5 million additional tons of high-grade ore per year. Every step in the process is carefully monitored from a central control room, which employs the latest in computer technology.
Morning, Rob. How things going, mate?
Great, thanks.
Did we go right in afternoon and night shift?
Night shift went well, afternoon was pretty rubbish.
Ah, good.
Stand clear of all dries in the dry screening area.
The output from the beneficiation plant is quality tested before conveyors move it to the product loading stockpile at the railhead.
Roger, 7-4, through Poondra at 9:12.
The 2-kilometre ore trains make an 8-hour journey along Mount Newman's 426-kilometre heavy haulage railroad. Journey's end for the ore trains is Port Hedland, where the next leg of the journey to the steelmakers of the world will be by ship. Nelson Point is a 140-hectare complex for the unloading, blending and shipping of more than 40 million tonnes of ore a year. The initial step is to unload the trains. Drawn by the electrically powered positioners, the fully loaded ore trains are moved through either of two rotary car dumping complexes. The most recently commissioned number 2 plant can empty 3 cars at a time without having to uncouple them from the train. The cars are tipped through 135 degrees, emptying their cargo into underground surge bins at the rate of 10,500 tonnes an hour. From the underground bins, conveyors lift the ore 50 metres to the top of either of 2 screening and tertiary crushing plants. The ore is separated into fines and lumps, with any oversized particles being recycled through the crushing plant to be further broken down and re-screened. Sampling stations, backed up by modern laboratory facilities and professional staff, monitor the ore flow at critical stages during the entire crushing and screening operation to make sure that product specifications are maintained. The computerized system gives operators precise control over the process.
The crush control. Your next 3 trains finds the D North 5 lump C area. Following that, finds D South 4 lumps E area.
Newman is justly proud of its special stockpiling procedure that ensures complete control of ore blending from mine to ship. 4 rail-mounted boom stackers handling 4,000 tonnes an hour lay the crushed and screened ore into special windrows. These are built into stockpiles up to 18 metres high. The Mount Newman project has transformed Port Hedland from a regional tidal port into the biggest bulk export port in the nation. Its sheltered deep-water facilities mean that 2 315-metre giants can load simultaneously. During the shiploading process, bucket wheel reclaimers work across the stockpiles, further blending the different constituents of the ore, minimizing the variations of the major ore components. Drawing from the port's 8.5 million tonne capacity stockpile, 2 rail-mounted shiploaders can each deliver fully blended ore at a rate of up to 8,000 tonnes an hour.
Loader 1, restart your belts, please. Loader 2, you can restart your belts.
The shiploaders can work together on one bulk carrier or separately to load 2 ships simultaneously. The 658-metre ore pier is one of only a few ports in the world capable of handling 2 220,000 deadweight tonne bulk carriers at the same time.
ship loading into this